Hello everyone. In today's lecture, we will see a new point from chapter number 2, second law of thermodynamics. And today's point of discussion is standard gives free energy. And in this, we will see want of reaction isotherm. Before that, what is meant by gives free energy? In the last lecture, we have seen gives free energy, Helmholtz free energy, and the significance of these free energy functions. So, most of the chemical reactions occur at constant pressure rather than at a constant volume because they are open to the atmosphere. And the criterion for the spontaneity of a process or a reaction for a system at a constant temperature and pressure can be obtained in terms of new state function, which is called as a Gibbs free energy. And Gibbs free energy is defined as G is equal to H minus Ts. We have seen this equation in the last lecture. G means Gibbs free energy, H is the enthalpy, T is the thermodynamic temperature, and S is the thermodynamic entropy. So this is the definition, and we have seen another definition, the change in Gibbs free energy, that is delta G is equal to delta H minus T delta S. So here delta represents the change, that is initial and the final states, because Gibbs free energy and entropy and the enthalpies are the state functions. These properties are dependent on the initial and final state of the system. And a standard free energy of a compound is determined as the free energy change involved in the formation of the compound at unit activity from the elements, and it is denoted by delta G standard. That is a standard Gibbs free energy. So we will start with want of reaction isotherm. So want of reaction isotherm shows a qualitative relation of the energy change accompanying a chemical reaction which has been developed, and this is known as want of reaction isotherm. For that study, we will consider a general reaction small a into capital A plus small b into capital B. It gives C capital C plus small d capital D. So here small a, b, c, d are the number of moles of the reactants and the products respectively. So here capital A and capital B are the reactants, and capital C and capital D species represents the product. So small a and small b are the number of moles of the reacting species, and small c and small d are the number of moles of the products, that is C and D. So the free energies of each of these substances per mole at a temperature T will be given by. So we can write equation for free energies for each of these species, capital A, B, C and D. So we will see how these equations can be written for free energies. So see, I have written here 4 equations. So Gibbs free energy, that is denoted by G, and the standard Gibbs free energy is denoted here by G standard. So for first reactant species capital A, we will write the first equation. Ga is equal to Ga standard plus RT ln of activity of A species. So here in this equation, this small a represents the activity that we have written here, unit activity. So Gibbs free energy is determined in terms of the unit activity. So here activity is included in the equation of Gibbs free energy. So J is equal to Ga standard plus RT ln of activity of A. Here we can write same equation for species B, C and D. So GB is equal to G standard B plus RT ln of activity of B, and then for C species, that is the product species C, is GC is equal to G standard C plus RT ln of activity of C, and the last equation is GD, that is gives free energy for D species which is in the product, is equal to gives free energy or the standard gives free energy of the species D is plus RT ln of activity of D. So we have four equations, 1, 2, 3 and 4. Here in this equation, this G standard are the free energies at unit activity of the various species, and small a into capital A, comma, small a into capital B, small a into capital C and small a into capital D are the respective activities of the species small a, B, C and D. Now, according to theory, free energy change of the reaction is the sum of the free energies of the products minus the sum of the free energies of the reactants. So, as we write the delta symbol, that is the free energy change of the reaction, and is the sum of the free energies of products minus sum of the free energies of the reactants. So, we will see the equation. See, delta G represents the change in Gibbs free energy, which is equal to, in a bracket, CGC plus DJD. Here C is the small c, this first species is the CGC. C is the number of mole, G is the Gibbs free energy and Gibbs free energy of the capital C species. So these two C are different. First C is the number of mole and second C is the C species. So number of moles into Gibbs free energy of the C species plus number of moles and Gibbs free energy of the D species, and bracket complete. This is for the products, minus activity of GA plus B into GB. Here small a and B are the number of moles of the reacting species and GA and GB are the Gibbs free energies of the reactants. So just according to this, we have written the equation change in Gibbs energy is equal to sum of the Gibbs free energies of the products minus sum of Gibbs free energies of the reactants. So just put the equations of CGC, DGD, AGA and BGB here. Therefore, delta G is equal to CG standard C plus CRT ln of AC. So this is the equation number 3 we are writing here. So see, this is our equation. GC is equal to G standard C plus RT ln of AC. So here there is a suffix C. So just write down CGC. C into G standard C plus CRT ln of AC, because here in this first equation CGC is here and we have only GC value is there. So multiply each term of GC by C. Next you can put value of GD here and just multiply D to this. So GD value is here. GD is equal to G standard D plus RT ln of AD. And here is the small d in our first equation. So you can write d into GD is equal to d G standard D plus d RT ln of activity of D. So just put this value here, d into G standard D plus d RT ln of AD. So this first bracket is complete and it shows the Gibbs free energy of the product. Now same way you can write the Gibbs energy of the reactant. So here in place of activity of in place of A into G into capital A, you can write the value of this from equation number 1. This value, just multiply each time small a into GA is equal to A into G standard A plus A into RT ln of activity of A. So I have written this terms here, plus same way you can write for B species, B into G standard for B species plus BRT ln of activity of B. So this is our equation. Now just separate the terms which includes the standard Gibbs free energy. So this equation can be rewritten as delta G is equal to, in bracket, just take standard Gibbs free energy containing terms here separately. So C into Gibbs free energy of the C species, that is a standard Gibbs free energy. I have taken this from here, plus D into G standard D. So this is our first bracket, minus, take same values from the second bracket also. So activity of G standard A plus B into G standard B. So I have written this here. Now the remaining terms can be written in another bracket. So just write here plus symbol and take second bracket. So same way you can write the values for product and the reactant. So initially you can write the values of product and then subtract the reactant value. So CRT into ln of activity of C plus DRT into ln of activity of D. This is our first bracket minus second bracket, and in this bracket you can write ART ln of activity of A plus BRT ln of activity of B. So this is the equation. Now just you can write down the equation CG standard C plus DG standard D. This is written here. Minus, write down minus symbol, minus activity of G standard A plus BG standard B. First bracket is written as it is, and for the second case you can write plus RT. So see, in this all terms, this is our second bracket which we have taken from this equation. In all these equations, the RT is common. RT, here is RT and here is RT. So just write down the RT terms here into ln of, here each term contain ln. So ln of, just write down positive values divided by negative values. So activity of C, activity of D is taken at the upper, and activity of A and activity of B is written here. So this is our equation of change in Gibbs free energy. Now we can write this is a, as we have defined, delta G is the change in Gibbs free energy of the product minus Gibbs free energy of the reactant. So just instead of this we can write delta G standard. So I have written here delta G is equal to delta G standard plus RT ln of activity of C into activity of D divided by activity of A into activity of B. So this equation is known as Van't Hoff reaction, isotherm, and here small ABCD represents the number of moles, capital ABCD represents the reacting species and the product species, and this small a in all four species represents the activity. So this last equation, delta G is equal to delta G standard plus RT ln of activity of C into activity of D raised to mole D divided by activity of A raised to A into activity of B raised to small b. So this is the Van't Hoff reaction isotherm equation. Now the first term on the right of the equation gives the free energy change involved when the starting material at unit activity react to form product also at unit activity, and this equation gives the free energy change of a reaction in the standard and the starting and final activities at any constant temperature T, and when the activities of starting and final material all are 1, then second term on the right of above equation is 0, that is it becomes delta G is equal to delta G standard. This equation will become 0 when activity is unit activity.